All right, let's start. My name is Ara Bernardi. I'm a principal PM in the remote desktop team. And thanks for coming to today's talk about designing a VDI architecture for scale and performance. In the VDI team, I own reference architectures and also all the scale and performance stuff. So this is directly from the stuff that I've worked with and stuff that my team has worked on. And at the end, if you guys have more questions about configuration, some more detail about the hardware and stuff, my LS is there. You can send me an email or just stop by and I can give you a little bit more context. So the agenda, the way I'm going to start is talk about VDI. Probably some of you have deployed Microsoft-only VDI, but some of you might have not. So I'll do a quick intro into VDI. If you've seen Adam's session, that was, I believe, B310, you already have a good sense. But I'll be pretty quick. And after that, I'll jump into doing the actual design of a 5,000-seat deployment. And while we're doing the deployment, we'll talk about performance and scale characteristics of the subsystem. I'll share with you guys the test data we have. Some of them is really recent, and we haven't published them yet, but we plan to publish this information eventually also. And time permitting, I'll show you the actual charts and so forth. And the takeaway for you guys, I hope, will be a deeper insight into Microsoft VDI architecture and the performance and scale characteristics, and what things you can tweak to optimize our VDI. So a word about VDI architecture. The system is very sensitive to workload. And when you're modeling for a particular deployment, you have to realize that task worker type workload doesn't use as much resources as a power user does. Or that a 9 a.m. rush login for the task workers between 9 and 9:15 demands a lot more resources than the knowledge workers logging in throughout the day. And when we do VDI simulations, we use different tools, and these are just simulations. The actual performance, the mileage vary when you do it on site, either at your site or for your customers. You have to be just sensitive that their workload might be different than the simulations we've done. So look at our simulations as a starting point, a guideline, but it's really important to understand what is the type of workload that your customers will be using. And the best architecture, the best approach to doing a VDI architecture is to understand what they mean, what your stakeholders mean when they talk about their performance requirements, turn those into system requirements, and start small, validate, tweak, and grow. As I mentioned, the VDI has got several phases that put different kind of load on the system. The provisioning, the initial phase of creating VMs and booting VMs is very expensive, but it can be planned for off hours. The login phase can be expensive if you expect your users to log in over a short period. And typically, what we try to optimize for and discuss is really throughout the day, what is the workload and what kind of performance and skills you expect for providing great response for that type of a workload. So a quick intro to Windows 2012 VDI. So on the right side, we have hypervisors that are hosting personal desktops, pool desktops with what we call user profile disk, which is a user profile and sessions. This is the traditional RDSH TS. And the RD connection broker is really the nervous system of our solution, where it has the whole topology of the deployment, configuration, and all the access control and user permissions and so forth. So it's responsible for identifying the user when the user connects and trying to figure out where's the best place for this user to go to. And the back end is a proper SQL deployment. On the front side, we have the RD Web, which is a web portal. A user goes to a website, logs in, sees some icons. Those are the resources that have been published to the user might be Notebook, for example, Outlook. You click on that. That icon starts a TS client running on the user side. And then that TS client connects to either the broker or goes through the RD gateway if you're coming from the internet. And I'll do a quick walkthrough of what these connections look like. So if the user is on the internet, they go to a website, HTTPS, they log in, and they see all the resources published to them. They click on an icon, and TS client starts. The reason they see all these icons and exclusive for them is because when they're logged into the RD web, broker sent the list of resources that the user was assigned to. And the broker, as I said, is the repository of this information. Every user will have a different view of the resources, obviously, available to them. It's per user, unlike before. Once the user clicks on the icon, a connection starts to the gateway, where, again, after authentication, the connection is routed to the RD broker. The broker authenticates the user and says, go to some destination. And step 5 is when the user or the TS client, without the user's knowledge, reconnects, and this time goes through the gateway and is routed to wherever the resource is located. If the user is on the internet, it's pretty simple. You just don't go through the gateway. You hit the RD web, you log in into RD web, and that results in the RD broker sending all the list of resources that the user has access to. User sees those as icons on the website, clicks on an icon. That starts a TS client that connects to the connection broker again. The connection broker authenticates the user for the second time, and this time it's an RDP connection. It says, okay, you should go to some resource which is there. So in a nutshell, this is how VDI 2012 works, and those are the key components of VDI 2012. We have when we talk about VDI, we really include pool VMs and PD VMs, but we also include sessions. These are the traditional TS in our VDI solution. And there's a value spectrum that I've captured from Adam's famous slide. And you see that each has its benefits and drawbacks. Sessions are the most cost-effective because a single operating system is hosting so many users. And it's very easy to manage RDSH since you just create a single image to which users connect to. The app compat is a little bit below what you would get on a client SKU because some applications just don't like running on the server, and users have a limited ability to personalize their session because they don't have admin rights. Pool VMs, on the other hand, are quite a bit better because they're just like running a client SKU. They are a client SKU. The only difference is being that user doesn't have administrative rights, so it cannot personalize, make configuration changes that are machine-level config changes. Ease of management is a bit worse than the session in the sense that you have to, when you update a gold VM, you have to create all these pool VMs, which are kind of like children of the gold VM. Unlike the session, once you create an image, users are running that image. And the last one is the personal VM. These are VMs just like your desktop that is assigned to you. You are an admin on that desktop, and that's why you can personalize it, including the machine configuration parameters, and app compat is great, but it's like managing a desktop. So the ease of management and cost effectiveness is no better than every desktop that is assigned to the user on their desk. So designing a large-scale VDI deployment. We'll do a walkthrough. The way I've put these slides together is that really I do a walkthrough of what it takes to do a 5,000 seat deployment and talk about, well, what are the design options? What are the scale and performance characteristics of the subsystem, and what can we tweak? And I've chosen that, from what we've seen, about 80% of users are on-site, on LAN, and about 20% at any time are coming from internet. So first, the VDI management servers. So it's a bit of a busy slide here, but on the right side, we have 2 hypervisors, and they're running all the management roles that VDI needs. We need the gateway. We need the RD web access for the web portal. We need the remote desktop license server. Our broker, that is really the nervous system of our VDI solution, and SQL, which is the backend storage for the broker. And Our components, they're HA at the application level. So you don't need to do clustering. Understand there's a model of SQL that requires clustering, so that's possible to do clustering also. We don't require clustering. Depending on what model of SQL you use, there's a model that does require clustering. There are 3 networks we're dealing with. The WAN, which is connected to internet through a firewall that connects to the gateway in RD Web. The LAN, which is your CorpNet, and the backend storage that is basically dedicated for all the Hyper-V storage traffic. And in this example, we're using a central storage for all the VMs that are booting from. All the VHDs are on the central storage, is a SMB scale-out cluster. In terms of performance, the RD gateway, we've tested to 1,000 connections per second per gateway. For any enterprise class solution, you really need HA. Therefore, means you need 2 RD gateways. And the connections rate we've tested is 1,000 connections per second at a data rate of 60 kilobytes per second. One of the benchmarking tools we've used is the VSI. If you guys are familiar with VSI, a modeling tool. I don't know if Mark is still around. There's Mark. And if you guys want to try VSI and get licenses from him, he'll be at the door and he'll be just giving you out free licenses. And this tool is becoming an industry standard, and we'll be using it among other tools we have in Microsoft to model VDI so that not only we get great insight into what our system does, but also it makes it easier to talk to customers and what it does relative to other systems. So coming back to the gateway, the throughput we've checked, 1,000 connections per second using that kind of data rate, which is what the VSI medium workload generates per user. And the configuration here is 4 cores and 8 gig on an E5-2690 class CPU. The RD broker, we can handle 5,000 connections in less than 5 minutes. Depending on the connection size, it can be a little bit low, a little bit higher. You need minimum of 2 RD brokers to have an HA solution. The SQL is the backend. It really does all the work. And to give you some examples, 50 concurrent connections in 2.1 seconds to a collection of 1,000 VMs. And the broker doesn't do much work. That's why it has only 1 core and 4 gigs of RAM for the broker. The SQL Server is doing real work here. Our database is pretty small. Only about 60 megabytes for 5,000 seat deployment. And I've captured a couple of test results. For example, provisioning VMs, it takes 1,100 transactions. I just realized that I don't have a slide to show you the load on the SQL when that happens. But the next one is user connection. Every time a user connects to our broker, we're talking to the SQL Server, and we're generating the 222 or so transactions. And I'll have graphs to share with you what the actual load, CPU load is on the SQL when we're handling these connections, because imagine when 5,000 users are coming in, that SQL Server is going to be busy for the period that the 5,000 users are logging in. The SQL config we've used is 4 cores. These are all virtualized 4 cores and 8 gig. And I believe that is the recommendation, minimum recommendation by the SQL team. So it's stuff to tweak when it comes to the management services we have. By default, when we create a deployment or we update an existing deployment, we update a single VM or create a single VM per host. And that's because we really don't know how much resources that host might have. But if you have a host that you do know that you configured such that there's plenty of resources, given the workflow you have, the period that you're going to use for doing such an update off hour, then it's then we can handle 5 creations, 5 updates per host. And by setting this parameter, you can actually speed up your deployment and provisioning update period by 2 to 3x, depending how fast your storage is. Next is the compute and storage. We'll look at 3 types of deployments. Pool VMs only. These are type of VMs where they're created from a gold VM, and there's a diff disk. And the mechanism for updating VM is really to recreate the gold VM with the patches and then update or regenerate the existing deployment. Then we'll talk about pool VMs, the same kind of VMs using centralized storage. And finally, we'll talk about a mix of a pool and PD deployment. So 5,000 seat pool deployment with local storage. So in this model, what we have is the compute and storage is local. And those are captured on the right side of the screen. So there are 2 OS boot disks just for the OS to boot, but then there's about 10 or so RAID 10 or equivalent 10K disks that are for the VHDs, for these VMs to run from. Since we're talking about pool VMs, we need to save user settings somewhere, and that is saved on the centralized SMB scale-out servers, and that's where the user VHD stuff goes. These don't need clustering because pool VMs, they're like throwaway VMs. You can log in into any other, and your settings is preserved, your documents are preserved because they're coming from the user VHD. And that's why user VHD is on some centralized node that is in an HA configuration so that there's no loss to user data. In terms of CPU usage, this is a Xeon E5 2690 class machine. And we benchmarked 150 VSI medium users at about 80% CPU. And that says you get about 10 users per core. Win8 uses more memory than Windows 7, so you need about 1 gig per Win8 VM. And so about 192 gig hosts should be plenty for this type of configuration. Our RDP traffic is about 500 kilobits per second for the simulation workload we ran, the VSI medium. That says about 2.5 gigabits for 5,000 users. So remember we said, hey, for this deployment, let's pretend we have 80% of users coming from or within the LAN, and about 20% are from internet. That's the type of load you will put on your network for 5,000 users. About 2.5 gig on your LAN, all the switches going into your data center, and about 500 meg on your WAN. In terms of storage, about 10 IOPS per user is the workload, the VSI workload, which we also think is the typical workload for a knowledge worker. The I/O distribution for 150 user is most of the reads. The pool VMs are primarily read-based, and gold VMs get about 70 I/Os per second. The diff disk get about 400 writes and about 150 reads per second. And the user VHD gets about 300 writes per second. Mostly it's write-heavy type operation. So this local storage, which is about 10K RAID disk, has to handle 850 reads per second and about 400 writes per second. The other 300 writes go on the network to the storage. And 10 or so disks should be plenty. So here's an example of a deployment that you can just add more capacity by rolling in new servers that have CPU and storage. And now you've just bumped up your deployment in the increments of 150 users. In terms of the storage size, this local storage, 5 gigs is the typical for the diff disk of the VMs. And each gold VM is about 20 gigs. So assuming you have several collections on a single deployment, few terabytes, 2 terabytes should be enough. Again, that should not be a problem with an array of 10 disks. The SMB load, so this is the load for the user VHD, which is all the user settings and documents and so forth. 2 IOPS per user out of the 10 IOPS per user we talked about. But we're talking about 5,000 users, and that's pretty heavy. We're talking about 10,000 write IOPS for this 5,000 users. Pretty significant amount. But the size is not that great. It's about 100 kilobits per second per user. So to size your storage, 10 gig per user for pool VMs. Depends on your scenario. You might need more. But if you go with 10 gigs, 50 terabyte of storage is what you need. And the overall network load, because of this user VHD traffic, is combining with the RDP traffic, it's only 3 gig by itself. Within your data center, isolated, is really insignificant. It's 0.5 gigabits per second. Tweaks and optimizations. If you replace 2 of those disks, array of 10 disks, with SSDs, you'll get a significant boost because about the usage of the SSDs will reduce load on the spindles by about 45%. So you can have less number of spindles if you use an SSD for a gold VM. And our configuration allows you to specify where the gold VM goes on the SSDs versus where the pool VMs are deposited, which will be on the spindle disk. Even if you don't need you have enough disk and you have not run out of space, if you have requirements such as faster login period or faster creation time, then using SSDs is the way to go. And for systems that have enough CPU and memory to host more than 150 users, we strongly suggest SSDs because you just don't have enough arrays on per server basis for that many users. Next, the same deployment, but this time instead of using local storage, we'll discuss leveraging an SMB central storage for the VHDs. So in this model, similar on the right side, we have the compute nodes, but there's no disk arrays on the compute side. Instead, everything is being deposited on the central storage system. So the cluster, the SMB cluster, scale-out cluster we have will be responsible for storing user VHDs, for serving the VM VHDs, and also serving the gold VMs. And in this drawing, I have the gold VM separated as an opportunity to use an SSD for that because it will be a different share. In terms of the CPU and MEM and RDP, there's no difference. What we discussed earlier is the same. The VDI traffic is the same, 500 kilobits per second for the medium user, and 150 VSI medium users per E5 2690 processor. But the storage now dynamics changes. Even though it's a 10 IOPS per user, now we got 50,000 IOPS for 5,000 pool VMs. And the distribution looks the same, but the key point is that the I/O load on your central storage is significantly higher. Sizing, 20 gigs per gold VM, just like before. Maybe because you've centralized now, you have 10 to 50 collections. That's about 1 terabyte for the gold VMs, probably on the SSDs. The diff disks are small, 5 gig, but they add up. You need 25 terabytes on your central storage. And the user VHDs, we discussed earlier, no difference. 10 gig per user says we need about 50 terabytes on the central storage. The requirements on your central storage gets really hefty. Network load picks up also. Now that we have the VHDs, the VMs booting from the VHDs stored on central storage, we're putting 30 gigabits per second traffic on the storage network, which is something you were not contending with before. But in this design, your data centers, dedicated storage network should be able to handle this. And naturally, you have 2x network for HA, and so you will need 2x capacity to deal with this network load. Tweaks and optimizations. So there are a lot of costs involved in doing what I just described, the SMB storage, the central storage, heavier load. Wow, why would I do this? But there are certain benefits too. So in 2012, we've introduced CSV caching. And CSV caching reduces the load on storage tremendously. And what it does is basically it loads, the hotspots are really loaded into the server, and the server's memory is what's used to satisfy all the requests for the blocks. We silence that. Sorry about that. So the average reduction in IOPS is 45%. And we see an 80% hit to the cache if you have a 1024 meg type configuration for the CSV cache. Neat thing is that if your capacity was storage bound, let's say you could not host more than 5,000 users, with the CSV caching, you can increase the capacity by 20%. So you'll be able to host on the same storage configuration 6,000 users. So it's a very big deal in really getting more from your storage, the CSV caching. And this is only available as part of the SMB scale-out. A couple of things to note is that CSV cache seems like it's like a gold VM. So you might say, well, what is the difference between the two? And the difference is that CSV cache is really using the server's memory, and that's a super fast memory. But once you run out of server memory, what you want to do is use the SSDs and put the gold VMs in SSDs to complement server's memory once it's maxed out. Okay, so we covered this. I was getting ahead of myself. So we said, yeah, average reduction in IOPS is about 45%. The one thing important to note is that CSV cache is per collection. So if you have 10 collections, you need 1024 megabytes per collection. Optimization, the only thing you should be aware of is that now that we have a SMB scale out and you have a farm of Hyper-Vs, you want to load balance which Hyper-Vs hit which scale-out servers. And there's a PowerShell for tweaking this so that there's a balance between the Hyper-Vs and the SMB scale-out servers. Next, let's look at a mixed pool VM and PD deployment. What we've seen is that pool VM is the common use just because it's a lot easier to manage pool VMs. And 80-20 breakdown has been the typical in my experience. So these are the numbers I've used. 4,000 pool VMs, 1,000 PD VMs. The equation a little bit changes because now all the Hyper-Vs have to be clustered, because unlike the pool VMs, if Hyper-V goes down, then the data, obviously, we want to make sure that the PD is available for the user and there's no interruption to that user's workload. So all the Hyper-Vs are clusters, but not a problem because we have 5,000 VMs, and in Server 2012, the maximum number of HE objects is 8,000, so we're below that. And the number of nodes is 64 for clustering, and we're well below that. 5,000 users, we need about 35 hosts. And in this model, all the load is on the central server. The storage has to be HA, especially for the PDs. And with that, we'll go to the slide discussing the workload. So CPU, memory, RDP load, no different. But the PDs are putting more load on your storage because they're not using a common image anymore, unlike the pool VMs. So even though we have 4,000 pool VMs and unlike 5,000, we have a little bit less load on the storage, the 1,000 PDs are putting a lot more load on your storage in the order of 6,000 reads and 4,000 writes per second. Sizing of the central storage for PDs is it's going to be more expensive. In our internal self-hosting, we started with 40 gig deployments per user. People ran out of space in no time. So now we're recommending 100 gig per user, and that says 100 terabyte just for the 1,000 users you have. The rest is really similar to what we discussed, 4,000 versus 5,000. So 20 gigs of gold VMs per collection. Maybe you have 10 to 50 in that range. 1 terabyte should be enough, not much. Diff disk, about 20 terabytes. User VHD is a little bit less because now we have only 4,000 pool users that are using user VHDs versus the 5,000. But you really pay the price with going to PDs. Network traffic, about the same. 2.5 gig is really the RDP traffic. The user VHD traffic is slightly less, but it was not that significant in your data center. The pool VM traffic has dropped down a little bit, but now we have the PD VM traffic that has gone up. So your data center's storage network has to handle about 34 gig or so per second. You need 2 of those to be HA. As far as tweaks goes for PDs, we don't have anything built in box, but storage size being the biggest burden on the PDs, we recommend hardware or SAN-based deduping to reduce the storage requirements. Because all these VMs are identical, pretty much, you get tremendous value by deduping. Okay. And one last thing I want to cover in GPUs before we talk about though when we talk about our vGPU, typically we're talking about the protocol performance. That would be a completely different topic. What I want to cover here is about sizing your deployment when it comes to vGPUs. In terms of memory usage, this chart shows the size of the screen and the number of monitors and how much memory the GPU must have in order for the VM to start. So basically we check to see if there's enough free memory in the GPU, else we don't start the VM. Now, as far as the runtime goes, what we've done is we've tested on our ATI FirePro V9800, 4 gigs of RAM, on a pretty nice AMD server 585 with 128 gig RAM, 70 users, 70 VMs per ATI FirePro. And we bumped it all the way to 100 VMs, but our server ran out of memory. So basically, the hypervisor didn't have enough memory to start these VMs. But a quick calculation says, you could, with 2 GPU cards, you should be able to host 140 VMs on this DL585 with about 192 gig memory. Okay, to recap, we discussed pool VMs on local storage, pool VMs on SMB, and a mix of pool and PD VMs on SMB. What's blue doesn't change. That's the point of the blue tint there. That is, these numbers stay the same, no matter which configuration you use. What changes is that once you go with the SMB, you have to have a bigger central storage, and once you have PDs, you have to have even larger central storage. And the IOPS on your central storage really goes high. And I haven't mentioned the IOPS here, but all the previous slide describes the IOPS, so you can just put it together and put it at the bottom if you're considering one of these types of deployments. What I really like about the top left one with the local storage is that the network is a lot less complex. The I/O load is localized to each host, and it's very easy to grow your deployment. You roll in a new host, now you have, depending on the capacity of your host or the type of host you have, 150, 200 more users easily without affecting the network without affecting the deployment, the network in your corporation or at customer site. Okay. So let's look at some perf and test results. Let me double check and see how much time I have. 4:30, ouch. Okay, so some background here. So we've been working with Dell to build and benchmark 2,000 plus seat deployment in our engineering center. And what I'm showing you is one of the servers that it's a Dell 720. We have 14 of these servers in a cluster as in a VDI deployment, they're not clustered, with the management services. And I've captured one of the hosts doing 150 users, Windows 8, x86, running Office 2013. And this is running VSI login workload, the medium workload. And you see that the left side of the screen is where the storage load is the highest and the logins are happening, and the red graph is the CPU. So the CPU is building up as the users are logging in, and there's a storage load. The read load is pretty high. Logins are read heavy. And once users log in and the VDI workload is running, we're doing pretty nicely. 150 users, the I/O load during the stress period was only about 1,000 reads per second, and disk write was about 700 per second. 10 local disks, RAID 10, does just fine. Now remember I mentioned to you guys about the broker load. So what I'm going to do is in the next slide, this is 2,000 users logging into our deployment. The deployment is spread out over 1 hour. And on the left side, you see the load on the SQL Server. And the scale on the CPU is really a 10x. So this, the capture right there says 2.4. So 2.5% CPU usage is what you see in that period, the 1 hour period that the users are logging in. Now, if you said, well, instead of 1 hour, I want 2,000 users to log in half hour, just collapse this load, and it will double in size, right? So if you want everybody to log in 5 minutes, basically you'll have a lot more load on that SQL VM, and it'll be within the 5 minutes, and the peak of the CPU would be probably about 80%. This VM had 4 vCPUs and 8 gigs of RAM. RAM is not a problem. I believe this baby is only using about 2 gigs of RAM. CPU load would be heavier if you try to log in more people. And on the right-hand side, we have the broker. The broker is just doing nothing. In this one experiment, we had 2 vCPUs, probably was too many. 1 vCPU would have been enough. And finally, this is the VSI medium workload total score for the 14 or 720s hosting 2,000 VMs. And it's all based on local storage. The only thing that is using the central storage is the management services we have and user profile stuff. Okay, next. So next few slides, I'm going to give you guys some insight into how our system behaves and what things change and why they change so you can plan around them. So in this example, we have DL585, which has got 48 CPUs, plenty of RAM, and there's really no load on the system. And what is happening is that we have about this period, we have 22 VMs logged on. And every time a user logs on, there's a spike on the gold VM, about 800 reads per second. And there's a spike, somewhat smaller, that is the load on the diff disk. So every moment that the user is happening, the storage is experiencing this read spike. The question is what's going on. So there's a configuration setting that we have, and this is the default. When you create a deployment or refresh a deployment, all the VMs are in the off state. When the connection comes, our broker wakes up the VM. It's really waking up from a saved state, which was the CAD state. And at that moment, we're reading a lot of information from storage into the Hyper-V's RAM, and that puts a stress of about 500 megs of data per second into Hyper-V's memory. And the storage you're seeing is spiking. We see the spikes because of that load. So if you don't want this spike to happen, just start your VMs before users log in. You can start all the VMs before users log in. Maybe on Sundays you do the patching, let the VMs run, and at the 9 a.m. when the user hit the system, you won't have these kind of spikes. So you can log in users faster. This graph shows the performance of our broker, single standalone broker, which is really not an HA configuration, versus 2 brokers using SQL Server as the backend. And the graph on the left shows 20 connections coming in concurrently for 1,000 VMs. And you see that by using the SQL Server, we basically are able to go twice as fast. And the right-hand graph shows about 50 users coming per second for a collection of 1,000 VMs. And compared to a single broker that takes 3.5 seconds to route the user to the right target, we will route it in about 2 seconds. And beyond that, it doesn't make much difference if you add the brokers, because brokers don't do much. It's the SQL Server that does the work. Next is the VM creation update time. So remember I mentioned to you about this concurrency value, which by default we create 1 VM per host during the deployment, the provisioning phase or update phase. And if your system has enough resources or it's underutilized during the period that you're doing an updating or patching, you can increase by setting that number to a 5. So this is the capture of that data. If your storage is capable, and the green curve and the black curve are type of storage that are capable, then the amount of time it takes to provision 50 VM, for example, the black curve, goes from 1 hour to about 27 minutes when the concurrency value is set to 5. It is similar for the SMB. Actually, the SMB was sitting in front of the SAN. But you see, if the storage is not capable, then there's not much gain. The difference between the black line and the dotted line is the black line is for the creation, and the dotted line is for patching, which is you've already created, you're just doing a refresh. terms of creation time and versus storage type, we compared it using just the DAS with SSD, 7 pretty fast 15K disks in RAID 0 with a single SSD versus SAN. And we were just excited to see that it was comparable. In real world, obviously, you would use the RAID 10, so you would need a bit more storage for doing this, but it's a neat curve to look at. So this one is about host memory versus storage. So this is, again, that 48-core AMD. We have 128 gigs of RAM. And the green curve is showing users coming in, and the number of partitions is just increasing. And the gold VM is the darker blue line. It's about 2/3 of the graph. You see that everybody is in this lower range, about whatever the 10 is, I forget. It's probably 1,000. It's 1,000 as in the number of IOs per second. But suddenly, about 2/3 through this run, we see a spike that the read load, the write load, the diff disk read loads jumps. So question is, what is going on in this period? Why did we get such a jump? What happens is that the available memory is actually going down. And moments later, after the available memory to Hyper-V goes down, we see that spike. And the reason is because Hyper-V is dynamic. I'm getting ahead of myself. I'll get to that, but it is about the interaction between Hyper-V's dynamic memory manager and the storage as a backend to the pool VMs. So I'm going to get to that because this is the most exciting part. So what happens is when the Hyper-V runs out of memory, it hits zero memory. The dynamic memory manager starts squeezing memory on the top graph from the guest VMs. So the guest VMs have less and less memory, which means they're starting to swap more. They're swapping more and putting load on the storage. So the key point here is that dynamic memory will help to increase the number of VMs you can run, but your storage should be able to handle the extra load when the memory in the Hyper-V is squeezed. Okay? And the previous one was just a sanity check. We've heard that, well, when the VSI medium workload puts about 10 IOPS per user on the storage system, and this has a detailed capture of that. So if you ever wanted to look at a reference drawing a diagram that says, here, what the Hyper-V workload looks like on the VSI medium workload, this has captured all that data. And finally, even though that DL585 was running out of memory and the pool VMs were being squeezed, we were able to run 227 VMs, and VSI max was not reached. So we thought that was pretty good performance. This experiment is it's the same DL585, and we had 24 10K RAID 10 disks as the local storage. We said, hey, for this 227, let's see if we can run it off of only 10K RAID 10 disks. And you see there's practically no difference between the disk queue, where we have about a third of the disks as before for 227 VMs. This experiment is about CSV caching, which I mentioned earlier, that really, really helps for central storage. The green curve at the bottom is the disk I/O that CSV cache did not satisfy. Okay? And the red one is the cluster cache reads coming from the cluster cache. So that's the cluster cache that is being satisfied. And the benefit, tremendous reduction in the I/O load and the read load on your storage. This was an experiment where we cold booted 40 pool VMs, and immediately CSV cache fills up, and the rest of the VMs are really reading the blocks from the cache. This is a similar experiment, except it's about the VSI medium workload, the runtime workload, the knowledge worker workload, unlike the previous curve, which is the boot, where 100 VMs are running VSI medium workload. And on one side, left side, we have cache on. And on the right side, the cache is off. And you can see the blue and green curves. Those are the IOs going to the disk, and how much less on the left side is the IO going to the disk. And the yellow and green curves are the CSV cache being satisfied. And this one is about the network load. So remember earlier we were computing how much your storage network should carry for booting 5,000 and running 5,000 VMs off of a central storage. This graph captures the amount of load each client, as in each hypervisor, is putting on the network for the 150 users we have. So the computation I've showed you earlier is really the summation of this and the multiplication across the 35 hypervisors supporting 5,000 users. So this is how you would capture the work or measure the workload, the network load, the workload will generate and provision the network for your data center. This one is about the vGPU. Remember I mentioned the vGPU earlier, how we ran out of memory on the hypervisor and we could boot only 100, not 140. So one of the things we discovered was that, so looking at the first one is the scenario where the hypervisor is not running out of memory. And we have the red curve, which is the number of VMs being generated, and we hit about 82 VMs, and we go steady. The middle curve, which is yellow-greenish, is the system memory, and there's plenty of system memory. And we have a single vGPU, we have a single GPU, and the GPU memory goes down to about 0, and we can't create any more than 82 VMs. There's a good experience for all the 82 VMs that are running with vGPU, but after that, you can't create more vGPU-based VMs, and that's that. So then you add a second GPU and say, okay, fine, I have more GPUs, I should be able to create twice as many VMs. Well, what happens is that even though the GPUs have more memory, we have more memory because we have 2 GPUs, our system, this is now the Hyper-V, runs out of memory. And when the Hyper-V runs out of memory, which is that pink line kind of going down, what happens is that it starts swapping. And every VM that is running, all the VMs that had no trouble, they have a counterpart in the parent partition of the Hyper-V that process is being squeezed and it starts swapping. So once your Hyper-V runs out of memory, all of your VMs will degrade the UX experience because the process that is dealing with the GPU stuff is being squeezed for memory. So the key point between these two curves is that it is really important to have memory, extra memory left for your parent partition when using vGPUs. And if you're seeing that your vGPU performance was great, but it started to get sluggish, look at how much memory you left in your hypervisor. And if that memory goes to 0, everybody's experience, vGPU experience, is going to suffer. Few closing words. So we've tested our inbox services, and we have a PowerShell layer that could be used to create and manage up to 5,000 seat deployments. We are building actual end-to-end large-scale deployment. I shared with you guys the 2,000 seat deployment we have. We're hoping to grow that to 5,000. We have Inbox Admin UI that is designed for 500 seats. So for smaller scale, we feel that the Inbox UI is okay, but for any larger, you have to use the PowerShell. And if we have enough time, I want to grab Sentinel and show it. There you are. So Sentinel on a single laptop has got Sentinels with Dell, and we've been doing this 2,000 seat deployment with Dell's assistants and Dell servers. And on his laptop, he's got the whole Windows Server 2012 VDI built on a single server on his laptop with 10 VMs. And I think we have a few minutes where we can show you guys. Yeah. Let's press 2. what the simpler user interface looks like in a VDI running on a laptop.
So Sarah talked about, is it the main RDS interface?
There's this one.
This is a simple management interface.
Hey, Alan, can you pump up the volume for your second mic?
Hello.
Yeah.
Okay. Sorry about that. So this is the simple UI interface Sarah was talking about for the admin, right? You see the RDS role as a part of key, main. This is the server manager. And now once you configure the remote desktop services, what you have is 5 roles, which Sarah talked about. Your connection broker, web access, gateway, licensing, and then you have your RD virtualization host running pooled and personal desktops, and then you have your session host desktops. So it's very simple, right? And you can go to collection, individual collections, and say you want to create, what's it?
Click on collections.
Collections.
And you say task, create.
Tasks. You can create a virtual desktop collection or a session collection, right? This is how you add users, more users to your session. Do you want to see a demo of what we are running?
Sure.
Yeah, sure. So let's go to the program.
So this is a preview of Senthil's talk. That's going to be B291 on Thursday.
So here I'm connecting to your connection broker, which we have configured, and I'm logging in as a...
So this is the website, right? This is the web portal that the user is connecting to.
So as you guys can see, we have published 3 desktops, right? Personal, pooled, and session host. Let's click one of those. You have a Windows desktop, right?
Here, so let's do this. Let's go here.
A full screen.
Move this guy. We go like this, so you can see here. So that's the RDP client, right? Just connect it to one of the VMs. It's a pool desktop. Everything's running on the same machine, right?
Everything is running on the same machine. I can even play a...
What's the spec on your machine?
It's not for sale. So even we can...
Is it an Alienware? This guy says...
this is a Prussian mobile
Dell.
workstation, again, just for pilot purposes if you just want to play around VDI, right? So you can see remote effects configured in this. It has a GPU card and doing multimedia redirection, right? Everything running through RDP8 protocol. Just absolute clarity. So
Nice.
that's pretty much it.
Okay. All right, guys. Yeah, I think we have a little bit of time for Q&A. Yep. I'm sorry.
Yeah, this is a local cache video.
So have you guys done any metrics on video across the LAN, capturing any refresh rates or whatever?
Yes. So RDP8 was, redesigned ground up to make it WAN multimedia friendly. And are you asking if we've captured data about that? So the numbers I showed you, 500 kilobits per second. So the VSI medium workload generates flash content as part of the workload for about 3 minutes, or so 2 to 3 minutes, I forget. And the 500 kilobits per second I was mentioning to you is the average of that VSI workload, which includes video. So if you're asking me what is the frame rate for something like that, with the vGPU, you get better than 25, 26 frame rate. With the Warp, which is the software emulation of the vGPU, for video, it's comparable. You will get 24, 25. The vGPU, I think it shows its true value when you have very heavy multimedia like spinning 3D, PowerPoint, DX-based PowerPoint that is creating this virtualization of stuff spinning through a presentation. That kind of stuff really demands the vGPU, and the software GPU emulation really comes short.
Yeah.
So for CAD drawing, you would need the vGPU, and on a LAN environment, it is like being it feels local. Yep.
There's a microphone here in the center, which might help us out a little bit hearing questions.
So the question is about optimizing, lowering read IOs or storage IOs. Putting the gold on SSD really helps. But if you're talking about, well, what can I do to generate less IOs? I can't. There's nothing I can think of. Using any form of caching, such as the CSV cache or the gold VM, putting on SSD really helps taking load off of the spindles. So that's how we've thought about this, that take the load off the spindle by using various forms of cache. CSV cache is an example. Using SSD for gold VM and isolating is another example.
There's also an image tuning session tomorrow that talks about what to do with your gold image to reduce I/O. Windows 8 knows it's running in a virtual machine, and it changes some of its behavior automatically. But there's other things like turn off the Bluetooth service because you can't use Bluetooth from a VM anyway. There's some other little things you can do that will reduce the footprint of that gold image. That is called Optimizing and Tuning Windows 8 for VDI, I think is the name of it. If you search for VDI sessions, you'll see it.
You guys touch on Windows 7? Some of us are not there yet.
Sure.
A lot of the same behavior, a lot of the same stuff is going to apply to Windows 7.
What's really important is installing the 8 IP on Windows 7 SP1, because that brings the stack improvements on the server side that we made in RDP to Windows 7 SP1.
And when is the session tomorrow? Thursday?
I'm not sure what time the session is tomorrow. I'm not.
It is tomorrow?
Yeah, there is one tomorrow on image tuning. And then there was a session yesterday that was an overview session that talked about all the WAN improvements for video and everything else. That's probably online now on the MMS website now if you want to go back and watch that recording.
4:30 in Laguna.
Okay, 4:30 tomorrow, image tuning. Thank you.
Yes. Yes. Yes.
The direct attached storage was a single disk. So the question was, why was the performance so much better creating and provisioning and patching disks on SMB or on SAN versus local storage?
Versus local or between SMB and SAN?
Well, then, but I think it's because on your slide that was just a single direct attached disk or two disks versus.
So I can pull up the slide.
Yeah, go back to the slide. It's basically you're just I/O bound on a single disk versus, a disk array that you'd have on the share or SMB. Oh,
I think
yes.
this is the one, right?
Yes.
Okay, so what's your question again?
Why is the blue one so much higher?
The blue is like a terrible storage. It's a weak. Blue storage is a local.
Okay.
The top one is a weak storage. Okay?
Yeah, if you look there, it's just 4 disks.
It's 4 local disks. Yeah. Wait, any other question? Yeah.
The slides should be up in the catalog
already
now.
available.
The slides should be there now. If not, it takes them about 24 hours to get the recording up, and they'll publish the slides at the same time as the recording. So,
Such as? Right. Okay, right. Yeah. I'm pretty confident about the 10. I have the data. can't sit down with Citrix and go over this.
Can you talk about what it's doing in that medium workload? It's opening Word, it's opening Outlook, it's editing documents.
Hey, BSI guys, you want to talk about medium workload, what it does? Okay.
You want to come use the mic?
That's a surprise, thank you. So, my name is Mark. I am the product manager for Login VSI. And the medium workload acts as a typical Office user. So it uses a lot of generic applications like the Microsoft Office suite. Doesn't matter which version. And it just starts working as your average employee. So it starts a few applications. For example, Outlook, Word will have a few applications open simultaneously and start working in them. Print a few PDF files, run through some PowerPoint presentations, but really average. Not too fast, not too slow. We also have a light user. The light user uses less memory, less CPU, and therefore, of course, we also have the opposite of that, which is the heavy user. The heavy user, of course, using a lot more CPU and memory. So I don't know whose question that was, but did I answer your question? Yeah, okay.
So using a local PST file for Outlook?
You could use a real Exchange server, but there's also a local mode because not every company has the size in their test lab to use an actual Exchange server, so then it uses local PST files.
Well, I think that's the key question, figuring out what the NIOPS really works. You're not indexing, you're not caching.
Right, yeah, I mean, it's opening a Word document, it's opening email, and it's browsing the web a little bit, but again, your mileage is going to vary. You can configure it that way. You could certainly take a fully populated Outlook cache and run the tests against that and things like that if you wanted to get a more accurate representation of what your real work scenarios are.
Yeah, you can customize it any way you want. So make sure to grab a card.
Any other questions for Ara? Any other VDI questions? Okay. We can take other questions too. We'll give it a shot. All right. Ara's going to stick around here for a little bit. If you have other questions, please come up. Thanks for coming, guys.